We are going through exercise 17e, and in this video we'll be answering question 10, which says the following. The curve y equals f of x, for which f dash x equals 4x plus k, where k is a constant, and has a turning point at -2, -1. Find the value of k. Okay, so before we jump into A, let's just take a step back and really appreciate what we've been given. We've been told that we have a derivative, so f dash of x, of 4x plus k. Now we can figure out what our f of x is going to be by undoing the derivative. So by undoing the differentiation, we can arrive at f of x. So we're going to be performing anti-differentiation on this. And if we were to do that, we would end up with 4x squared over 2 plus kx plus c. Then this would cancel with this, and I would be left with 2 here, which means f of x is going to be 2x squared plus kx plus c. All right, so we haven't yet addressed what A is asking of us, but what we do know is that our function is a quadratic, and obviously by finding the derivative, it's just a linear function. We know that. Now the question is asking us to find the value of k. So the value of k is going to be most easily found when dealing with the derivative. So the derivative is 4x plus k. Now, in order to find k, we're going to have to sub in another point. In the question, are we given another point? Well, we are. We're told that the turning point occurs at -2, -1. Now, to answer this question, what really needs to happen is as soon as you see the word turning point, alarm bells should be going off in your head, because when we're dealing with derivatives and turning points, we know something significant is going to happen. What is significant about the derivative at a turning point? What is significant about a derivative at a turning point? The derivative at a turning point is going to be equal to 0. So the fact that they tell us that at this point we have a turning point, what that means is that at f dash of -2, I'm going to have a gradient of 0. So over here, we are told that the turning point occurs at -2, -1. We know that at the turning point, my derivative is going to be equal to 0. Therefore, at f dash -2, I'm going to get a derivative that is equal to 0. Let's really visualize what we're saying here. So we know that our f of x is going to look like this. So this, what I've drawn right there, is just f of x. And we know that the turning point, so let's think, the turning point is here. And as you can see, if I was to draw a tangent at this point, it's just going to be a horizontal line, therefore the derivative is going to be 0. All right, so now we have to solve it now. So this is just merely a matter of subbing in what we know. So when we sub in -2 into this, -2 plus k is going to be equal to 0. Whoops, 0. So that means I'm going to get -8 plus k is equal to 0. Therefore, k is going to be equal to 8. And just like that, we have solved part A. Hopefully that makes sense. The real takeaway message is when we're dealing with derivatives and you see the word turning point, alarm bells should be going off in your head. Okay, let's now go on to B, where we need to find the coordinates of the point at which the curve meets the y-axis. So this is kind of worded a bit strangely. All it's really asking us is to find our y-axis for f of x. So let's come up here and, because we already found what f of x is going to be, it's going to be this. Let's bring this down. And we now know what k is going to be. K is going to be 8. So that means I can rewrite this as f of x is going to be 2x squared plus 8x plus c. Ooh. Now, before we can find what the y-intercept is going to be, we're going to have to solve for c. In order to solve for c, we're going to have to sub in a point. Do we have a point? We absolutely do, because we know our turning point is occurring at -2, -1. So we know this is a point at which lies on this graph. So remember up here, we are told that at -2, -1, we have a turning point. So that's what we're doing. So just to kind of hammer this home, if I come down here and I put this graph, our graph is going to look something like this. It's a quadratic, it's pointing upwards. This point right here is -2, -1. So that means if I sub this in, I can solve for c. So at f of -2, I'm going to get 2 -2 squared plus 8 -2 plus c is equal to -1. Let's now solve this. It's 2, 4 minus 16 plus c equals -1. 8 minus 16 plus c equals -1. 8 minus -16 is -8 plus c is equal -1. I then have to plus 8 to both sides, so c is going to be equal to 7. That means I'm now going to come back up here. This question is taking longer than I expected. I'm going to come up here, come here, come here, come here. This is 7. C is 7. If I now want to find my y-intercept, to find y int, let x equal 0. So I'm going to find f of 0. 2, 0 squared plus 8, 0 plus 7. So hopefully you can see where this is going. It's just going to be 7. So 7 is the y-intercept, is y int. And we should know that because it's just the last number on the end. We often say that c at the end is the y-intercept. So we really didn't have to go through this last step, but I just wanted to show you what was going on there. So that means if we were to come up here, this point right here would be 0, 7. All right. So I think that is everything that we needed to do for this question. It was a bit of a long one. Hopefully it makes sense. And before we end, it says find the coordinates of the point. So this is something where people would lose a mark in a test. You'd have to write your final answer as 0, 7 is y-int. So I know that's annoying. And you're probably thinking to yourself, I've shown that I understand just because I haven't done it like that, but we're preparing you for the exam in year 12 and they're going to be picky like this. It's a good way to take marks off people. So just be aware of that. Make sure you answer correctly. Did I answer the first one correctly? Find the value. Yeah, I did. All right, perfect. Hopefully that was helpful to you.